Students, before going to the applications, one more important point here. Before going to the applications, field strength of the ligands. Ligand field strength, another word is spectrochemical series of the ligands. This order is given based on the experimental evidence, based on the observation of the magnetic properties values based, this order is given ligands. So among all the ligands, which is the strongest ligand, which is the weakest ligand in this series? Here in this series, this one is a strong ligand region. This is present in the strong ligand case. I minus is considered as a weak ligand among all. So this ligand based, strength based complex compound magnetic properties are existing, stability is existing, color of the complexes also is deciding by the field strength of the ligands. So all the properties, what are the drawbacks are there? The drawbacks are overcome by this exploitation of the field strength of the ligands. Remember this order, students. This order is given based on the experimental evidence only. There is no choice to us how to give in the order. All competitive exams, NEET, JEE and other competitive examination also, this order is important. So once look at, observe all the ligands here. First one is a CO, carbonyl, cyanide, EN, ethane 1,2-diamine, amine, and EDTA, thioisocyanide, H2O, aqua, oxalato, OH minus, hydroxo, fluoro, florido, S minus 2, Cl minus, thiocyanide, bromide, halide, iodide. Look at, observe here, halogens are present in the weak ligand region case. Halogens. Fluorine, chlorine, bromine, iodine, which is the more electronegative element? Fluorine is the more electronegative element. As per the comparison point of view, halogens, fluorine is a strong ligand, after that chlorine, then bromine, least is the iodine, is the weakest ligand as per the halogens point of view. And one more here, H2O and OH minus ion. H2 and OH minus ion, which is the strongest ligand in the series point of view? OH minus ion is the strongest ligand. And oxalato and H2O. In these three, which is the strongest ligand? H2O is the strongest ligand, oxalato, then OH minus ion. Next, NCS, SCN, which is the strongest ligand? NCS is the strongest ligand compared to SCN. And the remaining four observed here. These any four is possible to given in the examination. Arrange the following ligands in the decreasing order of field strength, decreasing order of ligand strength. CO and CN minus, CO is the strong ligand. CO and EN, CO is the strongest ligand. EN and amine, EN is the strongest ligand. EN is the strongest ligand compared to amine. Amine, H2O, OH minus and C2O4 minus 2. In these four, which is the strongest ligand? Amine is the strongest ligand. After that, H2O. After that, C2O4 minus 2. After that, OH minus is the strongest ligand field strength order. Among the four, NH3 is a strong ligand. After that, H2O, then C2O4 minus 2, then OH minus. As per the series, you need to memorize. Simply here, carbon based ligands are strong ligands. First three, carbon based ligand. After that, nitrogen based ligands are strong ligands. After that, oxygen based ligand. Electronegativity based is given ligand strength order. Carbon based, nitrogen based, oxygen based, then halogens. Halogens are more electronegative, carbon is the less electronegative. Based on that, just memorize like that way. One point I am explaining here, crystal field splitting, orbitals are split into two energy levels, T2Z and EZ. One point I am connecting to the color property here. Observe carefully, color property. For example, the d orbitals are split into two energy levels. This is T2Z. This one is the EZ. This is the energy barrier. This is delta naught. T2Z, here the easy. Another complex, the 5d orbitals are split into two energy levels. This is T2Z, this one is the easy. Observe that first one and second one energy gap, first one and second one. The second one energy gap is more, delta naught value. Energy gap is more, here the energy gap is less. Energy gap is less. Splitting is less splitting, here the splitting is more splitting, that means energy gap is more. Energy gap is less in the which cases? Weak ligand cases. If the energy gap is less, that ligand is a weak ligand. If the energy gap is more, that ligand is the strong ligand. In the strong field ligand cases, more energy gap is existing. In the weak field ligand cases, less energy gap is existing. You know that already relation E is equal to H nu. That means Hc by lambda is a very important color identification. Energy and frequency relation directly proportional. Energy and wavelength relation inversely proportional. So energy increases, frequency increases, wavelength decreases, and wave number increases. So energy increases, frequency increases, wavelength decreases, wave number increases. Here the energy gap is less. Here the energy gap is less. Here the energy gap is more in the strong field cases. Energy gap is less means wavelength is more. Energy gap is more means wavelength is less. Very important. So here Vidyar color. So left to right in the Vidyar, what happens the wavelength? Left to right wavelength is increases. So wavelength here the more, here the wavelength is less. Wavelength is more, that is which cases? Weak ligand cases. Wavelength is less, that is which cases? Strong ligand case. Red color wavelength is more, energy gap is less. So the red color appears in the which cases? Red color appears in the which cases? Wavelength is more, na? Red color appears weak ligand cases. And these are appears in the strong ligand cases. So these are appears in the strong ligand cases, these are appears in the weak ligand cases. The color is given based on the energy gap. Electron is moving from lower energy to higher energy. Energy absorption takes place. Which energy of absorption is taking place, and that energy is related to that color. That energy is related to that particular color. So now look at the applications based on this point. So in the crystal field splitting, the energy splitting is important. Formula important, crystal field stabilization energy calculation formula, and octahedral and tetrahedral, which is lower energy, which is higher energy, and spectrochemical series, the ligand series is important. And this is the hint way observation, color identification. Strong field, weak field, which color is appears? Approximately I am saying, not exactly. Strong field, which colors are possible? So possible ability. Now look at the application, students.